You look under geometry on Fun Sock Friday. SWBA students will be able to form and interpret compound statements and truth tables. Okay, compound statements and truth tables. Fair warning, you know how I told you guys a lot of this would seem like it's not math last class?
Yeah.
This is where it really seems like not math today. Okay, sorry about it. It feels more like English today. But
11 and 12.
But here's why we're doing this. Okay. It's because we're forming up our way of thinking, okay? So even though it starts off with not math, it's because I can't teach you a new way of thinking and new math at the same time, because then you're going to get doubly confused. But if I teach you a new way of thinking with something you already know, like English, okay, and basic sentences, then you're going to have a lot better time understanding this new way of thinking, okay? And this new way of formatting, okay? Alrighty, so first things first, not only am I the realist, I'm going to write my name down. I don't know.
Mr. Kenny.
Okay. You wrote Mr. Kenny?
Yes.
Alrighty. Well, you did or you didn't. Okay. So we have a statement. A statement is a sentence that is either true or false. Statement is different than an opinion, right? Okay, so if you're saying a statement, it's either true or false. There are true statements and false statements. A true statement. Okay? The wall at the back of the classroom is gray. You guys ready for a false statement? Okay, Fun Sock Friday is boring. That's a false statement, okay? So there's true and false statements,
I
okay?
get sort of pressed when I don't see Fun Sock Friday.
No, it's a fact.
Yeah.
Okay, you should be. Whether something is true or false is called the truth value. It's called the truth value.
Why is the truth value of 0 what it does that?
I get actually depressed when I see Fun Sock Friday.
That's fair.
It's just been a hard
Now, statements, we represent them using letters because sometimes we have this entire statement and we don't want to write out the entire statement. So instead we abbreviate it and we just pick one letter, okay? So the main letter we use is P. So we represent it using a letter such as P. P stands for a proposition, okay? Proposition, because this whole thing that we're going to go through is called propositional logic. It's based upon something being proposed or brought up, and then it is seen as either true or false. So my proposition, aka my statement, would be the wall behind you is gray. Okay, that is true. That could be P. Whereas Q would be another one. We go to another letter in the alphabet. Okay, and we go to Q and we say, okay, well, Q could be the other statement that I said of Fun Sock Friday is boring. So P would be true because the wall behind you is gray. Q would be false because Fun Sock Friday is not boring.
If you do something else like say that well white.
No, because it's gray, so it's true.
No, for Q.
Oh, for Q, yeah, sure. I could say like the wall behind you is blue, and that would be false. Or I could call that R. Okay. So like I said, we're going to use it to math in math later, but we're going to start off with not math.
I know, but I want to know.
All right. Here's an example. Supplementary angles have a sum of 180 degrees. So this would be our statement, and we're going to call this statement P. So that way later, if we refer to it when we have our phone away, okay, we can call this statement P. Okay, when we have our phone away. Thank you. Okay. It is crazy. Okay, take your headphone out, please. Oh, okay. Supplementary angles have a sum of 180 degrees. Is that true or false? That is true, isn't it? So the truth value is that is true, or capital T. Okay.
What's that?
We also have these things called a negation. What does it mean if something's being negated?
It's going around it?
Okay, kind of going around it maybe. What are we saying, Seth? Cancels out, okay.
Take it away?
It taken away. It does the opposite of it. Okay, so if you're negating something, you're doing the opposite of it, and it's usually to kind of cancel it out, okay? Hey, Chris.
Break them out.
Okay. So a negation of a statement has the opposite truth value. So if a statement is true, the negation of the statement is going to be false. If a statement is false, the negation will be true. It's going to have the opposite truth value. We show this by a symbol. We do symbols all the time. We do squiggly P. The squiggly is read as not. So this is read as not P.
Is there a specific way the squiggly has to be squiggled?
No.
Okay.
Just make sure it's squiggly. Okay? Here's an example. So we had P earlier. Supplementary angles have a sum of 180 degrees. So now we have not P. Supplementary angles do not have a sum of 180 degrees. Did I change up the sentence a ton?
No, sir.
No, I really just added not, and I had to make grammatical sense. So I couldn't say supplementary angles have not a sum of 180 degrees. That wouldn't make sense. So we had to change it up and say supplementary angles do not have. So we had to add do not there in order for it to make sense. What is the truth value of this statement, not P? Is that true or false? That is false. Supplementary angles do not have a sum of 180 degrees. That's false, because they do have a sum of 180 degrees. So that statement is false.
That was opposite, so I thought that meant the whole answer was the opposite.
So it's the opposite truth value of the original statement. So the original statement is true, so the negation has to be false. Continuing on. Compound statements. What does it mean when when things are compounded? Put together, okay? So a compound statement or compound statements are going to be two or more statements joined by the words. I'm going to capitalize these so that way we know which two words they are. And or. So compound statements are two or more statements, and we combine them with the words and or.
And or like meaning.
I don't know. I italicized them.
I think they're uber mega important.
Yes. Okay.
I just made like the perfectest D ever.
So we have two types of compound statements. We have conjunctions and disjunctions. Conjunction, junction, okay?
What's your function?
Yes. So conjunction
Perfect D.
are compound statements joined by the word and. So when we use the word and, we have what we call a conjunction. And we have symbols for this as well. So if I'm combining the two statements P and Q, between them, I'm going to put this little caret. Okay, think about in grammar, when you're proofreading and you say you should insert a word here, you put this little caret in there, okay? Here's how I remember this one.
It looks like an A without the line.
Exactly. It looks like an A without the line. The A without the line stands for and.
Looks like a spike.
A and. And. Okay?
Peel thing, so it doesn't.
Compound statements, or conjunctions, it can be conjunctions, are true when both statements are true. We'll talk about what that means. I do.
It's like, and then
Now we also have disjunctions. So we have conjunctions, we also have disjunctions. Disjunctions are going to be statements joined by the word or. Very good, very good. Okay, so use the other word. Use or. So if it's and, it's a conjunction. If it's or, it's a disjunction. Or we have a statement as well. We flip the A upside down. We flip the A upside down. So the one that looks like an A without the line through it is and. A for and. The other one is or. I don't have a fancy way to remember that. Just saying it's the other one. Elizabeth.
In the arm, it's the way you do it, it's like up in
the way I write it. Okay. Apparently that's a special way, I suppose.
Well, no,
Okay.
I'm not special.
It
It's
is.
just not how I write my R's. It's just
Mm.
like
you write your K's like yours. What are you
Oh my gosh. Y'all go back to the case. Okay, Seth.
B is for vector.
There you go.
If you write K
Okay,
once,
direction and magnitude. Okay. So, disjunctions are true when at least
you'll write a K, you'll see.
one statement is true. We'll talk about what that means.
All you have to assume.
These K's always look like R's.
It's just write a K.
Okay. Questions on this part?
Write a K.
I understand it might not make perfect sense yet, but we're going to apply them. I think it makes more sense. So here below, we have some examples. We have these three statements, P, Q, and R. Notice they're different statements. We just start with P and we keep working our way through the alphabet. There are 7 days in a week. Is that true or false?
Yes.
That's true. So let's put a T next to that so we know it's true. Statement Q. March has 30 days.
No.
That's false. March does not have 30 days. If it says March has at least 30 days, that would be true. But it doesn't say at least, so we say it's false.
You have 31.
It does have 31.
Let's go.
Okay, where are we going? Halloween is on October 31st. Is that true or false?
True.
That is true.
It's always true.
So P is true, Q is false, R is true. Now what we're going to do is we're going to be given these three statements, P, Q, and R. We're going to write compound statements like we see listed here, 1, 2, and 3. Then we're going to determine the truth value of this compound statement, either of the conjunction or disjunction. So this reads as P and Q. P and Q. So what we're going to do is we're going to write P, then we're going to write and, then we're going to write Q. So P is, there are 7 days in a week.
We are legitimately just doing English.
I told you.
This is like 3rd grade English, or probably not. This is like 6th grade
Here
English.
we go to this K.
So I wrote P. There are 7 days in a week.
There's his K. Look at that.
Okay. Now I'm going to write the word and, because this symbol means and.
It still looks like an.
It does look like an R with the.
Then I'm going to write Q. March has 30 days. So it said P and Q in symbols. So I'm just going to write out P. I'm going to put the word and I'm going to put Q. There are 7 days in a week. That's P. And. That's and. March has 30 days. That's Q. Kevin.
Doesn't matter what order it's in.
Yes. Yeah, because it went P and Q, we have to put the P first. If it went Q and P, then we have to put the Q first. Great question. Now, there are 7 days in a week and March has 30 days. Is that true or false?
False.
That's false because March doesn't have 30 days. So even though part of it's true and part of it's false, we say the statement as a whole has to be false. This goes back to right above in the conjunction. In the conjunction, it said it's true when both statements are true. Well, even so, because P is true and Q is false, only one is true, so the whole statement is false. What? So we say the entire statement ends up being false because even just one of them was false. Okay, Bailey.
I just figured out something, and yes, it relates to math.
Okay.
It's basically like the whole like learning about like the whole like times, negatives, and positives. If it's both like, or if one of them, or both of them have like a negative or a positive side, it's gonna be like as is false.
Okay. Kind of like that, yeah.
And one of them have like, if both of them have a positive or both have a negative, that would be true.
So no, it's not going to work entirely that way.
Yeah.
We'll see with two falses it won't work that way. But with the other three scenarios, that is true. Yeah. So on number one, we just went through and said P and Q. So we wrote P and Q. And we assessed the truth value. 2, Q and R. Does anyone know what I might write here for Q and R? Okay, Elizabeth.
March has 30 days, and Halloween is on October 31st.
Exactly right. We're going to write Q. March has 30 days. Then we're going to write the word and. Then we're going to write our Q, our R, which is Halloween is on October 31st.
So that's right. You can't abbreviate anything. Or, I feel dumb.
I abbreviate all the time.
I don't know. I wasn't really paying attention, honestly. I've just been listening and writing out.
You know what? Hey, that's something. Okay. Now, for and, we would say that these both has to be true. So, is Q true? Does March have 30 days?
Yeah.
Yeah.
Wait, no.
No, that's false. Is R true, though?
Yeah.
So what's our overall truth value, though?
False.
It's still false because they would both have to be true when it's and. So we're not saying we just want one of them. We want both of them to be true for an and statement to be true. Okay? Ray.
Never mind.
Okay. I want you guys to try number 3, P and R. And then assess the truth value. Okay? Ryan, I'm going to have you help me out here. What do I write?
There are 7 days in a week, and Halloween is not.
Very good. There are 7 days in a week. And Halloween is on October 31st. Presley, is this true or false? True, because they're both true. P and R are both true. So the entire statement is true. Now, are these two things really even related, though? The fact that there's 7 days in a week and Halloween is on October 31st? No. But at the end of the day, they are both true in an and statement, and that's what we're concerned about.
I have a question.
Okay.
Okay.
What's your question?
Oh, okay. Can it be like P and Q or
R?
R?
Yep.
Okay, bet.
I don't know where we're betting. Okay, let's look at number 4. Let's look at the page. For your convenience, I put P, Q, and R on the board again.
Thank you.
Okay? Because I didn't want you guys having to flip over like 5,000 times. Okay?
It's gotta be a protein on there, 5 or 6.
Now, let's look at 4. Nice. Not P and Q. Not P and Q. There are 7 days in a week. Bailey, are you stretching? You want to answer me?
Stretch.
Okay. Who can tell me how I might write this? Okay? Kenny.
Wait,
What are you doing?
you write it like you did the first one.
Okay.
There are. Yeah.
Ray, what would I do?
No.
March does not have 30 days.
Not quite. Is it not Q or is it not P?
Oh, it's not P, so there are not 7 days in a week.
There are not 7 days in a week. And this one is and again. Now, do I change up my Q at all? No, Q is normal Q. It's not P, but it's normal Q. So, and March has 30 days. So the negation just changes up that P because that's all it's on. If we had not P and not Q, that'd be a different story. Okay? Now, what's the truth value of not P? Is not P true or false?
It's false.
That's false. Because the original P is true. And we also know that there are not 7 days in a week. That's false. And Q is false. So what's the truth value of this and statement?
Double false.
It is false. Because they both have to be true. Okay, Kenny.
Oh. So can it be? What do you call that when you're real squiggly?
Not
Not.
negation.
Okay. Yeah. So can you have negation on both of them? Like
Yep.
P and R.
Yep.
Oh. I should. Yeah.
Yep. All right, let's look at number 5. What's different on number 5 here? It's an or. Okay? Landon, help me out with this one. Very good. There are 7 days in a week. Or Halloween.
Sometimes I wish you could actually just copy and paste words.
Fun. Wouldn't that be nice?
Technically, we are copying and pasting, so we're writing them back down.
That's a good point. All right.
We're slow at it.
Now, is P true?
Yeah. We're using
Is
that.
R true?
Yeah.
Now, don't think of this as a normal or scenario where we're asking a question. Like this or this, and you're like, but they're both true, so how do I answer? Okay? It's not like that. This is saying, is at least one of these true? Is there truth in this statement?
Yes.
Yeah. So as long as at least one of them is true, the entire thing is true. So when we see the ors, don't think of it as we're asking a question like this or this and you pick one. You're just really saying, we're asking, is there truth in this statement? There are 7 days a week, or Halloween is on October 31st. Is even one of those things true? In this case, they both are. Writer.
So, why would you use or? Why not just use and all the time?
Great question. Why not just use and all the time? So for our ors, we'll have scenarios where just one of them is true. That's all we need to be true. So like maybe like either this or this happens, and as long as one of them happens, we're going to be okay, kind of a thing. Like you don't need both. Both could happen, you'd be fine. But even if just one of them happens, we'd be okay. Does that make sense?
Yeah.
Okay. Ray.
So when it's or, like let's just say if they said Halloween is on October 30th,
Yep.
so would it be true since you're using or?
Yep, it would still be true because we're using or. Yep. Kevin.
What the? Will P, Q, and R would always be true or false? Like all of them would be false, or all of them would be true, or to get that from false?
Are you saying in a different scenario, if we had different P, Qs, and Rs, could they all potentially be true?
Yeah.
Yep. And they all could potentially be false. And it could be any combination of them. Yep. You just have to assess each individual statement.
That's crazy.
Yeah, Kenny, did you have a question or was it answered?
No, I mean, this question.
Okay, good talk. Okay. Let's try. I want you guys to try number 6 on your own.
Oh, it was.
Chase, go ahead and read me what you have here for not Q or R.
March does not have 30 days, or Halloween
Very good. March does not have 30 days, or Halloween is on October 31st.
So then, is mine okay?
What do you have, Kenny?
March has at least 30 days.
No, sorry. I read yours wrong then. No, it would have to. You have to have the not in there.
When did you write?
'Cause-
Did you put at least?
March has not 30
I mean, it
days.
would still end up being a true statement, but it's not quite the negation. That's actually would be considered a different statement. It's different enough. Now, not Q will be true because March does not have 30 days. From our definition of having 30 days, it does not have 30 days. Okay? Bless you, bless you, rains down after this, forget. But R is true. Now, is at least one of these true? Yep, so it's true. Okay? I want you guys to try number 7. Ian helping out. So not P or not R. Go ahead and help me out.
There isn't 7 days in a week, or Halloween isn't on October 31st.
Okay. I'm going to change it to R not. There are not 7 days in a week. But same idea, right?
I have something else. I have there is not 7 days a week. I have in a week.
That would be the same thing.
Well, but it's like different.
Every other week we only have 4 days.
I mean, yeah, that could be acceptable. We have to be careful, though, when we change it up. Just because when we change it up like that, it could end up meaning something different. That one happens to mean the same. We have to be very
I'll
careful.
just write N in, or in.
There you go.
In.
I'm so confused about the and or. What is actually, like, nobody knows if it's or.
By
It's based upon the symbol. Because like you said earlier, the A and the ors. There are not 7 days in a week, or Halloween is not on October 31st. I think Ian actually said isn't on October 31st, which is actually the same thing. Conjunctions are fine here, okay? So you can put isn't instead of is not. That's fine. Okay, yes. What is the truth value of this? False, because not P is false and not R is false. So neither one is true. Questions on that? We're going to skip number 8.
Wait, do we have to do the G, like if the P is true, I have to write the T above?
Great question. Ray's asking, hey, Mr. Kossel, I noticed every time you did this little F and T above the P and R at the beginning. Do we have to do that? No. That's just something I'm doing to help keep track of what's going on. Does that make more sense?
Yeah.
Okay. Write your own? Nah. Nah.
Nah, boy.
Okay, he is. Okay. Continuing on. We're going to talk about truth tables.
Not gonna lie.
This is going to seem very weird to us. This is new. You've never done this.
What is that?
Okay? Well, you have. Okay? But most of you have not done this before. It's going to be new to us. It's going to look weird. There's going to be a very systematic way to approach this. So I'm going to ask you guys to kind of hang on here and grasp and try to grasp the system in which we're doing this, because that's going to help you out a lot. I've seen students try and do it in a different way, and honestly, it doesn't work that well for them. Okay? So I'm not trying to be mean and saying like, hey, you have to do it this way, but like, you have to do it this way. Okay? This is a lot of times I say you guys have a choice on you can do this at this point or this at this point. This time, really just kind of the one way to do it. Otherwise, you're going to have a really hard time. Okay? I'm not saying you can't get it right, but you're going to have a really hard time. Okay, so a truth table. It's a convenient way of organizing truth values of statements. So when we start getting these compound statements like the ones we just had, those we could figure out pretty easily, okay, without doing a table. But when we start getting into bigger ones, which we'll see here in today, it's going to be pretty hard to figure them out without a table. It's going to be pretty hard to figure them out without a table. So in this table, we have a negation table, a conjunction table, and a disjunction table. The negation table just says we have a statement P, and they're going to have the negation of that, not P. So here's our heading. Here's our columns. We have P and we have not P. Below it, we have the different scenarios that could happen. Well, P, our statement is either true or false, right? There's no in between.
Yes, sir.
Okay, so there's only two possibilities here. P is true or P is false. So now we say based upon whether or not P is true or false, we know what not P is. So if P is true, what is not P?
False.
So we're going to put an F there.
Oh, this makes sense.
If P is false, what is not P?
True.
True. Now we filled out the negation table. Tony, phone away, please. This is something you really need to pay attention to, okay? You've been doing well the rest of the lesson so far. Conjunction. Conjunction was our and. It's our A without the line through it, right? Like Bailey said earlier. Here we have P and Q. We have P as well as Q. We have two different statements. And then in our third column, we have our conjunction P and Q. So we're going to say, with our P's here and the Q's, now we have 4 different scenarios. Because not only do we have to worry about whether P is true or false, we'd also have to worry about whether or not Q is true or false. So our first scenario, they're both true. Second scenario, P is true, Q is false. Third scenario, they're flipped. And fourth scenario, they're both false. Did we miss any scenarios here? No, we covered all 4 of them. So now we have to say, okay, well, based upon what we have filled in, these different scenarios we have, these 4 scenarios, what will our conjunction be? So if P is true, Q is true, what is P and Q going to be? Ray? True. Next row, if P is true, Q is false, what is P and Q going to be? Kenny?
False.
Very good, because they both have to be true. Where are we going? Okay.
You gotta stop.
If P is false, if Q is true, P is false, Q is true, what is our conjunction going to be? False. And what about if they're both false? Then it's false. So we're saying, based upon these different scenarios we had from our statements, the following will either be true or false, and we can fill that in.
There's going to be a lot of false answers, aren't there?
All right, now we also have a disjunction. We have our conjunction, disjunction. Same idea with our disjunction. We have these 2 statements, P and Q. Just like before, we have the same 4 scenarios. Notice, are these 4 scenarios in the same order? Yeah, there's a reason we do that. Okay, we'll talk about this order we do it, but there's a reason we have this order here, okay? So based upon whether or not they're both true, so if they're both true, what would P or Q be, Kevin?
Well, wouldn't it be opposite?
No, so the P or Q, we needed at least one of them to be true. So is at least one of them true? Yeah, so it's true. Now what about if just P is true? What's P or Q? Is that true or false now?
True.
That's true. We only need one of them to be true. This is our or. Don't forget, this is our or, this is our and.
Oh, yeah.
Okay? So Tony, what's our next one? I heard you say it.
True.
Very good. And then following that?
False.
Very good. In the first 3, at least one of them is true each time. But in our last scenario, they're both false, so it's false. Now, we have a very systematic way of doing this, like I said. These tips are going to be important. We're going to write even a little bit more. The first tip, include columns for each statement involved. These are your normal statements, not negations, your normal statements. So P, Q, R, etc. If we keep on going, you just keep using the next letter. S, T, U, keep going. So this is going to be the first thing you do. Go and write that in there. This is the first thing you do. You include columns for each statement involved. So at the start of each of these truth tables, we had our normal statements. The very first thing left to right we put was our normal statements. P, P and Q, P and Q. Second, go and write that in there. This is second. You would include columns for any negations that you might have. So if you have a negation, you would put that after your statements. You'd put that after your statements. Kenny?
Have you ever seen a list that they didn't put in order that wasn't for like a problem that you had to put in order? Because I don't think I have. So I don't know. It's just I'm confused why we have.
I don't understand your question, I'll be honest.
Why do we have to put first, second, and third? Like I would assume that you put it in order. Because
Yeah, I'm just double checking.
the third one even says lastly. So,
Yep.
I mean, we can
The
assume
third one does say lastly, so we can't assume it comes last. But I want to make sure that everyone's on the same page. This is a double check here.
Okay, makes sense.
So lastly, we're going to include columns for compound statements. So if you have both the negation and a compound statement, a conjunction or disjunction, you'll put those conjunctions, disjunctions last.
Your belt is really distracting.
Why are you looking at his belt?
Okay,
It's bright and
America.
it's one of those days.
Okay, questions so far? I know this is weird. Okay, so we're organizing our different scenarios here. We're just organizing different scenarios. Now, I'm going to give you guys some tips here, okay, as we go through these. So we're going to try and construct a truth table for P or not R. P or not R. Okay, can you put it away?
Okay.
P or not R. So what's it say is the first thing we're going to include columns for?
P
The
and
statement.
The statements. So in this case, we have P and we also have R. I know it shows up as not R, but we're going to put normal R in there, and we'll see why in a bit. Okay? So put P and R in there. We don't have Q because Q's not in there. So now we did the first thing. We did the normal statements. What comes second? Elizabeth? Not R. Any negations? So we're going to put not R in there. Now we have one more column. What's going to come last?
The whole thing on that.
The disjunction or conjunction. In this case, it's a disjunction. P or not R.
Yeah, that's what my family is.
Now, we're going to create, how many scenarios does it look like we have here? 4. We're going to start with our scenarios based upon our normal statements. You always fill in your normal statements first. Okay, so what we're going to do is we're going to say, well, if we look up above, there are 2 scenarios where P was true, and there are 2 scenarios where P was false, right?
Wait, where'd you get all that information?
All which information? The true and the false?
Yeah.
Okay, so we're creating all 4 possible scenarios, right?
Oh.
So let's back up a second. If P is true, we also have the scenario where R is true, right? They're both true. Then we have the scenario where P is true and R is false, right?
Yeah.
Then we have the scenario where we flip them. P is false, but R is true now. And then we have the scenario where they're both false. So if we look what we end up having here, we see the first column, the P's, end up going half of them are true, half of them are false, right? And what did our next column end up doing?
Half true, half false.
Half true, half false, but how? It's not the first half, second half, it's now alternating.
Yeah.
So the first one we went first half, second half was true and false. This one we said we're going to alternate true and false. Ray?
So do you always have to put them like that then?
Yeah, we're always going to put them like this. Once again, this will just help us so much. Okay? We'll talk about this more and more. Now, as we get into not R, we can use one of our previous columns to help us. Which column can we use to help us?
R.
R. So this one we're just going to put the opposite of whatever's there because it's not R. So if R is true, what is not R? Then what would be the next one? Then, and then? Very good. So it just does the opposite of whatever R is. Now when we get into our last column, P or not R, how many of those do we need to be true for or?
2.
1. You just need 1 or 2 to be true. At least 1 to be true for P or not R. Which 2 columns are we going to look at for P or not R?
P and not R.
P, not R. We're going to look at these 2 columns. So we're going to look at the first and the third column. We can kind of ignore the second column for a moment. We just use the second column to make the third column. We use the second column to make the third column. Now, we just need the first and the third column because those are the 2 that it uses. So, true and false. So what's P or not R? True.
Read 2 or false.
True or true. So it's
True.
true. False or false.
False.
And then false or true.
True.
True. So now we ended up saying, okay, well now we can know, based upon any scenarios, whatever our statements are, we could figure out what this ends up being. So we could just include any random statements. So now Kevin could give me 2 statements for P and R, and we could figure out whether they're true or false, and then we could say, okay, well, here's what the or statement would end up being for P or not R for any random statements. Writer.
So, say there's 2 negations.
Yep.
You just add another column.
Yep.
Look at number 4.
Yeah. Yeah, and we will try that on number 4 there, okay? So let's look at number 2. Not P and Q. So what's going to be our first 2 columns?
Not or
P and what's the next one?
Q.
Q. So our first ones are always going to be our normal statements. You do the normal statement for any letters you see show up. So even though we only see not P, we're going to put a statement in there for P as well. Then what's going to follow? Not P, any negations. And then lastly, what do we put?
Not P and
Not P and Q, the entire conjunction. Now, once again, we want to make sure we cover all 4 scenarios here, and I gave us kind of a trick to do that. So instead of thinking through each time and saying, okay, well, they could both be true, one of them's true, the other one's true, they're both false, we can do this little first half, second half thing I was talking about. So the first thing, usually our P, will always follow the first half of them are true, the second half are false. So we'll do true, true, false, false.
Every time.
Every time.
Without fail.
Every time, without fail. Then the last of our statements, it's not always going to be the second of our statements, but the last of our statements, which happens to be second this time, the last of our statements will always alternate true, false, true, false. And now we ended up covering all 4 scenarios. This is just a pattern we use to help us cover all 4 scenarios without taking as much time and thinking through all of it.
Are we ever gonna do this
With
with numbers?
numbers?
Yeah.
No, this is just a way of thinking on this one. This part,
Can you do it with numbers though?
we could do it with statements involving numbers. Hey Quinn, what's up?
Where do I sit?
I'm gonna have you sit right here today.
Here?
Yep. All right, not P. Can anyone tell me how not P would go? Top to bottom, Seth. Yep, it's gonna be the opposite of our P column.
Are we taking notes?
Yep. Great question. Not P and Q. Not P and Q. Which 2 columns are we going to look at?
1 and 3. 2 and 3.
2 and 3. Not P and Q, or Q and not P. And now this is and, so how many need to be true for it to be true?
1.
It's and, so how many need to be true for it to be true?
None.
Both of them. 2 of them. Ray.
Why didn't you organize it like you did the last one? Because you put false, false, true, true for not P,
Yep.
and then you did for not R, as for false, true,
It
false.
has
So
to-
the nots, the negations are always just going to be the opposite of whatever the statement there are. So not R is just the opposite of R. So because R was true, false, not R has to be the opposite. Because P is true, true, false, not P has to be the opposite. Kevin.
What if, like, it's, so the longer one, I'm on 4, like, it would false, true, like, what would you say, like,
Sorry, say that again, buddy.
so, for number 4,
Yep.
you went false, true,
Number 4,
yeah,
like down here.
yeah.
You're way ahead of
I'm
us.
saying, yeah, and it's 2.
Okay, let's stay up here for now. Okay, we'll get down there in a bit. Let's stay up here for now, okay? Let's not go too far ahead yet. Okay, so not P and Q. We're going to look at not P, the third column. We're going to look at Q, the second column. And for and, we need both to be true. So here, true and a false. So what's this value? We have false and false. What's the value? True and true, what's the value? And false and true, what's the value? So we end up getting these truth values from this one.
You know, I just couldn't tell if that was a Q or a P for a second.
Okay, continuing on. We're going to look at number 3. Number 3, do we have P anymore? No, but we still have 2 letters, Q and R.
Not Q.
Somebody help me fill this one in.
Q,
I got this.
R, not Q.
Okay.
Q, R, not Q. Kenny, go ahead and finish it off for me.
Well, then you just write it out. You just not Q and R.
Or R.
Or R.
Okay? All right, so we start off with the normal Q, the normal R. Even though we don't see a normal Q, because not Q shows up, we're going to put normal Q in there. Now, once again, the first column, we're going to do what? True, true, false, false. First half, second half are true and false. Very good, Tony. Second column, in this case, the last statement we do. Go ahead, sorry. We're going to alternate for our last statement. Okay, true, as I not alternate.
Wait.
True, false, true, false.
So, the third column will always be true, false, right?
It's gonna be false, true.
No, this one in this case is going to be the opposite of whatever Q is.
Second column, I meant.
The
not
second
third.
column will not always be the alternating. The second column, the last statement, in this case, because there's only 2 statements, the second one's also the last. We'll talk about a scenario that happens later when that's not the
Well,
case.
then the second scenario could be like
Okay,
true, false. Just the
we'll
same.
get there. So this ends up being true, false, true, false. So not Q ends up being what?
False, false, true, true.
False, false, true, true. It has to be the opposite of our first column, Q, because it's not Q. So now we go to our last column, not Q or R, not Q or R, and we're going to look at not Q as well as R. So we're going to look at our second and third column, the two columns before it. Now for OR, do we need them both to be true or just at least one to be true?
At least one.
At least one. So, true and false. Is it true or false?
True.
True. Next column, false and false. True or true?
True.
False or true?
True.
Wait, what? How'd you get false for the second one?
Because they're both false. We're looking at not Q, which is the third column, or R, which is the second column. Yep. You have to be very careful you're looking at the right column. Okay, Kevin?
So for 3, at the bottom, like the last one, we did false, false, true, and that equal true. Why is 2 not the same as false, false, true, false? And that's false.
Why is it not the same as the second one?
The bottom,
Yep, this. Why isn't it the same as this?
and the number 2 in the bottom one. Why are they the same thing, but they equal different?
Great question, because we're looking at different things. Here, this is an and, so we needed them both to be true, and they weren't. Here, this is an or, we only need one of them to be true, and it is. Does that make more sense?
Yeah.
Great question, okay? Let's look at number 4 here. We have 2 negations, don't we?
Yes, sir.
Okay, can somebody help me fill this in? Kenny, you got this one?
I guess.
Okay,
You can do it, Kenny.
P, R, not P, not R.
very good.
Then, not P and R.
And not R.
And not R. Not
Very good. P, R, not P, not R. And then our entire thing, not P and not R. So we have to put both negations in this time. That's our only change here, both negations. We still have 4 scenarios, so how's our P going to start off? First half, second half. First half is true, second half is false. Our last normal statement, our R, is going to do what? Alternate true, false, true, false. Now we can know not P will be the opposite of P. So since P went double true, double false, what's false, false, true, true? What's not R going to be?
False, true, false, true.
Kenny, what's up?
When I write my and, I put an A for.
Christian, I'll have you sit over there in the yellow chair, okay?
Alright.
You have to pass.
I always put when I.
You're like putting an A instead of the line. You're not supposed to put the line. Okay?
That you won't have that wrong.
I might. Not P and not R. Which 2 columns we're going to look at here?
3 and 4.
3 and 4 columns, 3 and 4. Not P as well as not R. We just look at those 2 columns. And it means they both have to be true or one has to be true. Both. So, can somebody read me top to bottom what this last column would end up being? Raise your hand. Okay, Bailey.
False, true, true, true.
I'm going to disagree with you on the second and third. I agree that it goes false and then the last one's true. Ryder, help me out.
Thinking that's nothing.
So, the second false and true.
And why are the second and third false, Ryder?
Bless you.
Because it's an and statement.
Very good, because it's an and statement, so we need both of them to be true. Okay, if this was or, then Bailey would have been right. It would have been false, true, true, true. But it's not, so it's false, 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 true. Questions on this one? All right. Okay, we're going to skip number 5, because number 5 is very similar. We're going to try number 6, though, because number 6 got a little bit bigger. Now we see parentheses. Wait a second. In parentheses tells... Guys, stop. Parentheses tell us to do what in math?
Do them first.
Do them first.
Let's go. I know Bauer's operation.
Now, we're going to... So that means we're going to do that conjunction before we're going to do the big compound statement. Okay? But we're going to still start off the same way. We're still going to put our normal letters. Now, how many normal letters do we have? 3. So what am I going to start off with?
P, Q.
Wait, but that makes.
I'm going to start off with P, Q, and R. I'm going to start off with P, Q, and then R. Because we have 3 normal statements. So we're going to put all 3 normal statements. Do we have any negations to follow? No. So we look at our compound statements. So we have to say, okay, which compound statement do we put? We have a couple. Kenny, what's up?
Well, if you do the order operations like we've always been taught, that means you have to do what's inside, and then whatever that came out to be true or false. True
Yep.
Or false.
Very good.
That and put it over in there so that way.
So we're going to put the one in the parentheses first. Because we're going to do that first.
I feel like I got this right. And I don't
Then we're going to do the entire compound statement because P is with or the entire Q and R.
No, that's
Your last column will always be in the entire thing.
That's not.
Your last column will always be the entire thing. Kenny, I think it'll make more sense when we get there, okay? Kenny, take a deep breath. I think it'll make more sense when we get there.
You're stressing me out here.
Okay, so I'm not telling you to take a breath. Now, we have a lot more scenarios now, don't we? We have 8 scenarios now instead of 4. What are we still going to do with our first statement? We're going to do the first half and then the second half. So I'm going to do the first 4.
Oh, it's or. Oh.
The first 4 as true. The last 4 as false.
You're gonna mix in the-
Now I kept being very careful in saying the last statement we alternate. So in this case, is Q the last statement? No, it's the second. R is the last statement, so that's going to be the one we're going to alternate. True, false, true, false, true, false, true, false, the whole way down. So that raises the question, well, Mr. Costle, what do we do when there's 3 statements? What do we do for the second one?
I have an idea.
It's no longer the last. Okay? Kenny, what's your idea?
Would it be the opposite? So it'd be false, true, false, true.
Nope, that's a good idea though, but it's not. But that wouldn't work. So what we need to do is instead is we're going to do double true, double false, double true,
You should have been.
double false. Now, if we go through and look at each of these 8 scenarios, they are all unique. They are all unique. None of these repeat, and we end up covering all 8 possibilities this way. This is the pattern that'll help us. The first one will always be the first half is true, the second half is false. The last statement will always alternate. And if we have 3, the middle one is doubles. Double true, double false, double true, double false. Okay? Kevin.
With the key, I think you want to answer this, but every time you have parentheses, the second one will be double true, false.
Not necessarily just because of parentheses. It'll be whenever we have 3 statements. So it's about the number of statements we have. Yep. So now, because this Q and R came in parentheses, we're going to do this next. So Q and R involves the second and the third column. And means they both have to be true. So true and true makes true. True and false makes false because they both have to be true. We keep going down. Only one is true, it's false. Neither are true, it's false. Both are true, it's true. And the rest of the way, only one or neither of them are true.
That's crazy, dog.
So we used our second and third columns, and the fact that and means they both have to be true to tell us our fourth column.
Okay, now.
Questions on the fourth column?
Yeah, I have a question.
On this column?
Well, it has to do with that.
Okay,
column.
I have a question on the fifth column. We're going to get to the fifth
Yes.
column now. P or Q and R. So P is the first column. Q and R is the fourth column.
I'll bet
So we're now
that's-
looking at the first column and the fourth column, and we have to have or. So how many has to be true? Even just one. So we look at the first column and the fourth column, because that's the 2 it involves. So in the first row, true and true makes true. In the second one, true and false makes true.
See,
We keep going. There's at least one true, there's at least one true, there's at least one true. Oh, they're both false, and they're both false.
see,
So Kenny, did that end up making more sense?
that's why I kept asking, but I couldn't portray what
That's
I
why I
wanted.
wanted you to wait, because I told you I'd get there.
Yeah, it was
Trust me.
very.
Ray, what's up?
I'm confused on the third part, the Q and R.
This one?
Yeah, like what'd you look at?
I looked at Q, I looked at R, and means they both have to be true. So they're both true, it's true. They're not both true, not both true, not both true, both true, true. Not both true, not both true, not both true. That make more sense? Okay. Okay. Now notice the columns can get bigger and bigger and bigger, but we're really just going to continue to do the same thing. The only thing that changes between 6 and 7 is 7 throws in a negation as well. So you just have to put the negation where it goes. We're going to end our notes there today, though, and I will pass out our homework because I'm a meanie head.